Title: Mastering Mechanical Leverage, the Critical Role of Mechanical Leverage in Paintless Dent Repair. Introduction. In the paintless dent repair (PDR) industry, a comprehensive understanding of mechanical anchorage principles is crucial for achieving optimal repairs. This entails the mastery of the leverage system, including the control hand and push hand, and the use of appropriate tools and techniques for manipulating metal surfaces. By harnessing the power of leverage, technicians can efficiently repair vehicle dents without the need for paint or fillers, ensuring the highest quality outcomes for vehicle appearance. The role of mechanical leverage in paintless dent repair. In PDR, the triangle is formed by the push hand, the control hand, and the tool, which are the essential components used to manipulate the metal surface of a vehicle. When technicians hold a tool and approach a dent, they face the challenge of determining what to push against. This is the first important factor of the triangle, the tool that the technician holds. The second and third factors are the technician's, the most important tool. When examining the mechanics of PDR and the human body, you will note that the tech harnesses two significant components, the control hand and the push hand. The control hand, which is typically your dominant hand, is responsible for controlling the placement of the tool onto the metal surface. Precision and accuracy are essential in this role, as the control hand guides the tool to the targeted dent. On the other hand, the push hand is the primary force behind the actual repair of the dent. It is responsible for applying pressure to the affected area and determining the subsequent direction of the push. The push hand serves a dual purpose of exerting force and controlling the tool's precise location, ensuring it is in the correct position. PDR technicians can gain an edge over their competitors by understanding and mastering the roles of the control hand and push hand in the leverage system. By critically analyzing ways to expedite the process, technicians can enhance their awareness of the techniques they employ and the reasons behind their choices. Such reflection leads to more efficient and high-quality dent repairs. Types of leverage. PDR utilizes various methods to manipulate the metal surface. The first technique, known as pushing leverage, involves the technician applying pressure either directly to the metal or through a leverage point. The second technique, pulling leverage, involves the use of hot or cold glue tabs to extract the dent from the damaged area. Lastly, twisting leverage utilizes specialized tools like Stanliner's pirate hook to twist the metal surrounding the damaged area and restore it to its original position. This technique is particularly beneficial for repairing dents in hard-to-reach areas, such as around door handles or window edges. Technique for manipulating metal. PDR involves manipulating the metal surface of a vehicle using specialized tools. Most paintless dent repair tools have a bend towards the end, which is referred to as the kick. Ideally, the technician holds the rod with one hand close to the head of the metal rod, control, and the other hand near the back, push, with a platform in the center. The platform acts as a fulcrum, which is the point at which the rod pivots when force is applied. The load arm is the distance from the fulcrum closest to the technician. This is where the technician applies downward force onto the rod, resting on the fulcrum. Everything behind the fulcrum is considered the load arm. The effort arm, on the other hand, is the distance from the fulcrum to the tip of the rod, with the bend or kick reaching up to the metal. When the technician pushes downward on the load arm, the rod moves upward from the fulcrum, lifting the effort arm and putting pressure on the kick, which in turn manipulates the surface of a vehicle. Points of leverage. There are various ways to create leverage, including making holes, using existing holes, wedging a tool between the bracing and the surface, using a hook, or by placing your arm into a sling to make direct pushes. These methods help to distribute the force more evenly and allow the technician to apply precise pressure to the damaged area. The number of points of leverage in paintless dent repair varies depending on factors such as the dent's location in relation to the vehicle, the dent size, and the tools used. Therefore, there is no specific, predetermined number of points of leverage. In most cases, however, there is a single point of leverage, such as in a simple lever system of placing a tool inside of a factory hole and pushing on the vehicle's skin, while in other instances, multiple points of leverage can be used simultaneously to distribute force more effectively and increase control. The leverage system consists of three components: the fulcrum, the pivot point, the effort force, the force applied, and the load force, the force resisting the movement of the object. A single leverage point is often referred to as a fulcrum. In PDR, I refer to the primary leverage point as a platform or Druckstützpunkt. Since my wife is German and I lived in Germany for 10 years, I derived this term from the German words Druck, pressure, and Stützpunkt, support point. Druckstützpunkt emphasizes the role of the single point fulcrum in providing support and applying pressure to reshape dents. To me, a Druckstützpunkt is the pivot point or platform in a lever system around which the lever rotates or tool rotates. The positioning of the Druckstützpunkt in a lever system can greatly impact the amount of force required to move the surface and the distance it travels. Understanding the lever system. When the fulcrum is positioned closer to the load, the distance between the fulcrum and the effort force increases, resulting in a larger lever arm for the effort. As a consequence, a smaller amount of force is required to move the load due to the increased mechanical advantage provided by the longer lever arm. This principle of leverage allows the technician to manipulate difficult dents and resistances with relative ease. However, it is important to note that while the required effort decreases, the distance the effort force must travel increases, which means more work is done in terms of distance covered. This trade-off between force and distance is a fundamental aspect of leverage, which enables users to optimize their efforts based on the specific situation and desired outcome. The dent dial tool employs this leverage principle, allowing technicians to create effective leverage points within relatively open spaces, such as vehicle cavities. For instance, beneath a truck bed, there is frequently a void or open area. In cases where a dent is located in the lower third and cannot be leveraged from the tire or above, a technician can bend the dent dial to push against the vehicle's frame. This versatile tool takes advantage of the leverage concept, providing an efficient and practical solution for accessing and repairing dents in challenging locations. Lever arm length and effort. As the distance between the effort arm and the fulcrum increases in comparison to the load arm, both control and power diminish. For example, consider removing a dent on your car's door panel using paintless dent repair tools of varying lengths. It is relatively easy to access and fix the dent using a short, 4-inch tool that provides ample control and precision. However, if you were to use a 12-inch tool and could only apply force at the tip, the task would become more challenging, but still achievable with practice and skill. Finally, imagine attempting to repair the dent with a 32-inch tool without being able to touch the panel directly. This would significantly increase the difficulty of the task due to the reduced control and precision resulting from the increased tool length. This example demonstrates how the choice of tools and their lengths can impact the ease and effectiveness of paintless dent repair. In conclusion, mastering mechanical leverage is critical for successful PDR. By understanding and skillfully applying various techniques such as pushing, pulling, and twisting leverage, technicians can effectively manipulate the metal surface of a vehicle without causing damage or using fillers. The leverage system in paintless dent repair consists of the control hand, the push hand, and the fulcrum or Druckstützpunkt. The positioning of the fulcrum can greatly impact the amount of force required to move the surface and the distance it travels. Additionally, the choice of tools and their lengths can impact the ease and effectiveness of PDR. By utilizing techniques to create leverage, technicians can apply precise pressure to the damaged area, gradually working the metal back into its original position, leaving the vehicle looking as good as new. Ultimately, understanding the importance of mechanical leverage and how to apply it effectively is essential to achieving optimal results in PDR.